Morning, everybody. Wolfie here. It's a fine, colder than a witch's tit morning here in sunny Orlando, Florida. Got ourselves a nice chilly bit of weather here for the past couple of days. But, you know, it cuts down my electric bill, so hey, I'll take it. So I'm off to go on another run here for groceries. And yeah, it's been a weird night. I couldn't fall asleep, so I have technically been awake since I'd say about 6 a.m. yesterday. So I am going on 26 hours awake, and I don't feel tired in the slightest. I don't know what the deal is. I mean, I'm not like confused easily. I don't get. I mean, I'm fine to drive. Except I forgot my glasses. Whoops. Frickin' Daystar. Jeez. Oh, I hope that's not a... Okay, good. That's a little bit of debris. I was like, oh God, I hope my windshield's not cracked. Hey! My rearview mirror is being a tard. Clearly it does not like cold. Quit it. Stupid technology. Had to roll the windows down because they're fogged up. Well, not fogged up, but they got condensation. Roll another one down. Woo, it's cold. Fucking mirror. Nope, I want that. There we go. I need to see behind me, asshole. Right, but anyway, so I've been awake now for 26 hours and don't feel even slightly tired. I'm lucid. I don't seem to be getting distracted easily, he says as he plays with his mirror. Shut up. Yeah, I spent the last couple of hours writing some benchmarks to test out some, to find out which of 3 strategies for a particular task was the fastest. And performance testing is fun because, you know, sometimes there's multiple ways to approach a problem in whatever language you're using, and in some cases, what seems like the obvious fastest option turns out not to be. And it's also the case that sometimes when you use, you might call it syntax sugar or shorthand to have the language sort of expand on what you type, on what you punch in, and take the correct action. It works, but it's not the fastest approach. Oh shit, that just turned. Well, this road's torn up again. Oh good, someone came behind me too. Oh, don't take that the wrong way. So specifically what I'm talking about, and here comes geek mode, there were 3 different approaches to this that I wanted to test, and here is the problem. Say you've got, this is all in JavaScript, by the way. This is running on Node.js. I think they're on version 14. I got to check with the DevOps guy. But, yeah, so it's running Node.js, which means we've got access to ES6 and all the fun extra syntax and functionality that it gives. So, given an array of objects, we want to get, and then all the objects have the same structure. They've got different fields or properties, and the one we care about is ID. We just want the ID out of it, out of each object in that array. And we want to stuff that in a new array, just the IDs in a new array, with no duplicates. So, algorithmically, this is a pretty simple problem to solve. You can do it in, as I've discovered, you can do it in one line of code. You can also do it in, what did it come out to? 3 lines of code. And spoiler, that's the fastest. And you can also do it with about 5 lines of code, which is the second fastest. As it turns out, the one-liner is the slowest option. I think I already said that, so maybe I am getting tired. The first option you've got is the 5-line one. At least that's the first one I tested. And you start with a for loop. You iterate through every element in the array. And inside the for loop, you check the array that you're building for the specific element that you are considering adding. And you do that check using the array indexOf function or method. And that tells you if the value you're searching for is in that array, is in the target array. And if it isn't, then it goes inside the if and pushes the value onto the new array. And if it is in the array, it just skips it and moves on. So, 5 lines of code. You have the for loop, the if, the push, and the closing brackets. That's it. And at the end of that, you've got your array with guaranteed unique values in, or no values repeated more than once. So that's the first way. The second way, and the first way is just using arrays. No special tricks, no nothing. The second approach is to use something in JavaScript that's been there since ES5 that a lot of people don't realize is there, because you typically don't work with these things. You don't even think of it. And unless you've gone through and read the spec, or you come across this in the wild, you may not have ever heard of it. It is called the set. A set, technically speaking, is a class. You have to create one by saying let foo equal new set. So you're calling a constructor to generate a set, or create an empty set. You can create a set from an array, and it'll let you do that. And I'll get to that. That's part of the third solution. But we're in the second one. And all you do is, instead of setting up an array, an empty array, you create an empty set. And the cool thing about a set is that it will not allow you to put to add the same value twice. If you try, it just ignores you. So there's a function you call, or a method that you call on your new created set called add. And you just put in the value that you want to add to the set. If it's already in there, nothing happens. If it's not in there, it gets added to the set. So it's basically doing that if, that indexOf if check, it's kind of doing that for you. Then at the end, you still use a loop. You still iterate through your original array of objects. But inside the for loop, you just call myNewSet.add, and you pass in the value that you care about. And then at the end, you've got a set of unique values. And to convert it back to an array, when you're done, you just say, const my final, my unique IDs equals array.from, and then in that function call, you pass in the set. And boom, it just transforms it into an array, and off you go. You've got an array of unique IDs. So that's the second solution. The third solution uses some ES6 syntactic sugar, namely the spread operator, it actually does a bunch of stuff all at once. The third solution I did, it wraps everything into one line, And it just occurred to me that I need to test something else, because my third method uses the spread operator and also uses array from and a map internally. So that's two things different that I should test separately. Anyway, so it's all done on one line. In square brackets, you enclose everything. You start it inside the square brackets with 3 dots. That's the JavaScript ES6 spread operator. And you just feed it the return value from array.from, and inside that you do new set, and inside the parentheses, inside the constructor for the new set, you say array.from again. You give the original array of objects, then as the second argument to array.from, the very innermost one, you write a quick closure, something like I, equals greater than, then curly brace, return, or actually no, you don't have to do that. It's I equal greater than, and then I.id. And then that just returns, that does a map, real quick array map, that just fetches all the IDs out of all the objects and turns that into an array. And that's what array.from does. So that returns an array, and then that array gets fed into the set during construction, in the set constructor. And then that whole thing, then you've got a set, and that gets passed in as an argument to array.from on the outside. And that produces an array. So ultimately, you have square brackets, ... your array. And what that does is it just it explodes the array into an array. And I just realized I don't think I need to use the spread operator. I can just use the array.from. I don't have to spread it. So, whoops, I got some adjustments to do on my tests. I may be doing this may be slower for no good reason. But anyway, yeah, that one-liner, as you've just seen, one-liners are not always the best option, because there's a lot to reason about in a single line of code, and that can get confusing, like it just did for me. And so, in my test, the second approach, just using a set in a for loop, was the fastest. But now that I've thought about it, I might be making a second copy of the outer array when I only need to do it once. So I may not need the spread operator, and that might improve performance and also simplify the call. So if you get rid of that outer bracket and the 3 dots, that makes it more clear, because then you just have array.from new set, array.from original array, and then the map function. So yeah, that might be quicker, and it's going to be clearer to read too. Anyway, I'll test that when I get home. But that's the idea. So 3 different ways to do the same thing. And I checked at the end that all 3 result arrays match. The same order, the same values, the same length. They're a perfect match. So all 3 methods work. And so I ran that, I iterated it 1,000,000 times. Rather, I created an array of 1,000,000 objects, all with IDs ranging from 1 to 1,000, or 0 to 1,000, whatever. And so I ran it through, and we're talking milliseconds here. It only takes, like, at least on my PC, it only takes about 80 milliseconds. The slowest one takes 80 milliseconds. So this is fucking fast. No matter how you do it, it's really fast. But I noticed that the one-liner took about 3 times as long as the for loop with the set. And then that one, let's see it. I think the one-liner was actually 60 milliseconds. Then the set, the for loop with the set was maybe 20 milliseconds. And then the first approach with just an array, iterating through the array and calling indexOf to do the search every time, I think that took like 28 milliseconds. So the first two approaches really aren't that far off from each other. And so I don't think there's really no perceivable difference. So I'm inclined to, all of this started from a code review that I wasn't even on the code review, but I saw, yes I was, I approved it. And then the guy that hired me went through, and this was somebody else's code, but he went back through and said, yeah, I think I'm going to do this thing to check for unique IDs so that we don't have to, we're not hitting the database too hard. And I noticed that he used the same, copy-pasted code like 4 times. And it works, and it's fast. But then I thought, you know what? A set can do that, I think. But if I just suggest it, he's going to pin me down about performance. Like, is it faster? Because this is an API we're working with, and yeah, you want it to be as fast as possible. The less time you spend doing everything, the better. So that's what prompted me to do the benchmarking stuff. And because it reduces code complexity, and it's faster, it should be an easy sell. I'm just going to put in the comments like, hey, check out this snippet that I put together. Here's a benchmark that shows this different approach. It makes the code a bit cleaner, and it's slightly faster. So, ta-da. Yes, I'm still in impress the boss mode for the new job. And then I tried I thought about the one-liner, threw that in there. I'm going to change that, though, and retest it. But, yeah, are they? Yeah, I'm the only car here. Fuck it. So, yeah, I'm going to submit that when I get home. And that's what happens when you can't sleep and you're bored out of your mind. But hopefully that'll be useful to everybody to see, hey, I actually tested this. And so that was kind of fun this morning. A nice exercise to keep my brain going. Be right back. I return. So that's what I spent my morning doing. Overnight, I almost pulled the trigger on a $2,700 laptop. Then I realized that's fucking stupid. It had really good specs. It was a nice looking machine. 32 gigs of memory, 1440 display, a Ryzen 9 8-core beast that can boost to like 4.1 gigahertz, a Radeon 1060, not a Radeon, an RTX 2060. Here we go. BRB. My orange juice is leaking. my leaky orange juice has been replaced with a non-leaky orange juice. Yay! Right. Oh, shit. Where was I? Apart from pulling that cable out of my... Right, never mind. Yeah, laptop. So, I was all the way through getting to the payment part of the checkout, and I'm like, you know what? This is stupid. I should not make a decision like this at 2 in the morning from my bed on another laptop that works perfectly fine and has no mechanical or technical problems with it. So, yeah, I really can't afford that kind of expense. Not after spending almost $3,000 on guns. That kind of blew my budget for the month. I should, This is not the time to go one of those in for a penny, in for a pound type rationalization. Nah, I got to keep that under control. I'll be good. And really, my current laptop works just fine. There's nothing wrong with it. There's this, I don't know. I have an itch to get a Ryzen-based laptop with a dedicated GPU, or a discrete GPU, because this current one's got some, Intel in it, and it's just got the integrated graphics. There's no discrete GPU, so it can't run games for shit. And the touchpad's a bit annoying too. It's not very accurate anymore. I don't know. I've tried cleaning it. That didn't help much. But, it still works. So I shouldn't replace it. Not until the smoke comes out, or magic smoke comes out. So there was that. And then as I was looking around for laptops, I was looking at the technology board on 4chan, and there was a discussion about Apple and their laptop offerings. And I have a MacBook Pro provided by work, to do development on, and it's a decent machine. And I went and looked it up, and it's for the specs, it's not actually that overpriced. They charge an arm and a leg for extra storage. That's ridiculous. I think the stock configuration is 256 gigs of SSD storage, and to double that to 512, they want $200 extra, which is just fucking insane. Since, compare the price of a 256 gig SSD and a 512 SSD, and it ain't $200. It's a lot less than that. You can get a 512 gigabyte SSD for pretty sure under $100 now. But whatever, that's just the standard Apple premium markup crap. So, I looked at that for a bit, and I guess they have some new chip. It's their own design of an ARM chip, an ARM platform chip, called the M1. And of course, they're boasting like crazy that, this is the fastest CPU we've ever put in a Mac. I'm kind of sitting there with a raised eyebrow, like, really? You got an ARM-based system, and you're calling it faster than your old MacBooks? And as it turns out, they're faster than the old MacBooks for two reasons. The first is that that the old MacBooks, even the 2019 MacBooks and MacBook Pros, and the Airs, they throttle themselves because their cooling solution is garbage. The fans are, noisy and they don't move as much air as they should. The heat spreader doesn't even, I forget the details, but it doesn't even completely touch the CPU. Like there's an air gap or something between the CPU and the heat pipe. So that's weird too. But the short version is that all MacBook Pros before the M1 version get too hot, and so they throttle themselves back, and that screws their benchmark scores and their performance overall. It's kind of sad. You spend $2,000 on a top of the line MacBook Pro, and it can't run at 100% CPU for more than about 5 or 10 seconds before it falls to its knees and slows down so it doesn't melt. That would piss me off, but I don't, I didn't pay for this one, so I don't care too much. Oh, man, that stinks. I'm back at the bit that's under construction. God damn, sewers are smelly. Oh, it's awful. Ugh. But anyway, the second reason M1s are the M1 MacBooks are faster. And that's the main reason that they're faster. They don't overheat. They can run at full blast 100% of the time and they don't melt. And they don't throttle. And the second thing they did to make things nice and fast is, I guess, they adhered to the ARM spec, which they have to do. They're through their license from ARM. And once you conform to the requirements of the ARM platform, like the instruction set has to match, behavior has to match, and certain features have to be there, that sort of thing. You're free to add your own extensions or add your own shit. And so what they ended up doing is adding a whole bunch of they added a bunch of tech from pipeline branching and memory handling that Intel and AMD chips use. So in other words, x86. So they borrowed a bunch of the design for pipeline and branch prediction and that sort of stuff, so that the M1, when it's emulating x86 code, it basically comes close to native x86 speeds for a lot of stuff. Because Apple has this emulation layer called Rosetta that allows this ARM CPU, which is a completely different architecture from x86, to run x86 code, which is kind of cool. Got to give them props for that. That's some neat tech. And so they added a bunch of kind of x86 magic that only gets used when running x86 code. And what ends up happening is they're not emulating as much. They don't have to translate 100% of the machine code. They can just pass it unchanged to the bits of the CPU that understand those x86 instructions. So that's kind of nifty. They still want too much fucking money for those things, though. Then, for a real laugh, I went and looked at their, what do they call them? Mac Pro. The desktop beast. The one that looks like a cheese grater. And they start out semi-reasonably priced, but the specs are kind of shit. And these are still Intel boxes. They're not M1s. If you want an M1 desktop, you have to get a Mac Mini. And that starts at $700. And if you want more memory, you want to go from 8 to 16 gigs, it costs like $100 extra. And then the same pricing scam for the SSDs. So you're looking at $1,000 if you want a decently spec'd Mac Mini with an M1 chip in it. But the Mac Pros, the big desktop Macs, they don't run M1s. They just run Intel. The bare bones installation, or the bottom of the line Mac Pro, has 8 gigs of memory and 256 gig SSD, an 8-core, I think it's an 8-core Intel chip, and whatever, and then integrated graphics. So I went nuts and used their configurator to build the beefiest Mac Pro I possibly could. And it's beefy, I'll give them that. 24-core Xeon chip with multi-threading, so you got 48 threads, something like 140 gigabytes of RAM, 8 terabytes of SSD space on one device, and 2 custom Radeon cards that each have 2 GPUs on them. So a total of 4 GPUs all bolted onto this motherboard for some random Mac Pro. And what else did I add? There was some other option I'm forgetting. But the punchline was the total price that they wanted for a fully decked out Mac Pro. $50,000 fucking dollars. I am not kidding. Okay, it's like rounding up from 48.5, but, you know, once you're into that range, you can round up to 50. But mother of God, that's, oh, right, there was some coprocessor. That's like $2,000 coprocessor that helps with video encoding and decoding, some shit like that. So, if you really want to use one of these things for video and video production, audio editing, disc authoring, that kind of thing, I mean, I'm sure with those specs, it's a monster of a machine. But fuck, man, that money, that's just insane. That's more than some people make in a year. That's the kind of machine you put on your insurance policy. Like, explicitly, you tell your homeowner's insurance or your renter's insurance, yeah, I have this now. Here's the receipt. Fucking cover it. Tell me what I have to pay you to make sure it's covered. Anyway, yeah, Apple's overpriced, blah, blah, blah. That's it for me. I got groceries to haul in and work to get to. So, hey, it's Rugen. I'll catch you guys later. Thanks for listening to The Ramble. See ya.